Good day, everyone. We are from Bachelor of Engineering and Technology, major in Mechanical Technology. First year students from Technological University of the Philippines, Taguig. Fifth group in our subject course, Welding Processes Laboratory. We were assigned to discuss the welding repair materials, tools, and equipment in gas, tungsten, arc, welding. And I am Maria Mikaella P. Delfin, reporting. Without further ado, and before anything else, we would like to introduce you to the definition of GTAW, which stands for Gas, Tungsten, Arc, Welding, in American Welding Society, and it might as well be called TIG or TIG welding, that stands for Tungsten Inert Gas. Gas tungsten arc welding is a process that produces an electric arc maintained between a non-consumable tungsten electrode and the part to be welded. To give you more details about our topic, gas tungsten arc welding is used to weld steel, stainless steel, nickel alloy, titanium, aluminum, magnesium, copper, brass, bronze, and even gold. For the field of application, TIG or TIG welding is commonly used in the aerospace industry and in the other areas such as in vessels, tank or boiler fabrication, aluminum casting, pressure valves or regulators, pipe fittings, or even in bicycle frames.
Hello, I am Cesar Ricardo Obligacion, and now we will proceed to the welding repair materials, tools, and equipment. First, we have the tungsten electrode, which is considered to be the critical component of the process, and this is defined as a non-filler metal electrode used in arc welding. This has the highest melting temperature among pure metals at 3422 Celsius or 6192 Fahrenheit. This means the electrode can emit an arc that heats and liquefies the workpiece without itself melting away. As you can see on the table, tungsten electrodes are classified into four types and are identified by color code. Based upon observation, it shows that a pure tungsten electrode has a lower current carrying capacity with A, C, and is rather more prone to contamination. Compared with pure tungsten electrodes, thoriated tungsten electrodes have higher current carrying capacity and it has better electron emissivity, longer life, greater resistance to contamination, meaning it associates an easy arc initiation, better arc stability with these electrodes. It is also said that TIG welding is considered to be the most difficult among welding processes because the welder must maintain a short arc length. Great care and skill are required to prevent contact between the electrode and the workpiece, as both hands are used, one to feed the filler metal and the other to move the welding torch. These tools will be tackled by the next reporter.
Before that, you need to know first the types of tungsten available for use with GTAW. I am Sheanely Dondoyano speaking. TIG welding can be done using a variety of different tungsten types. Some of these include zirconated tungsten. These particular tungsten's alloys typically employed on welds that require a high AC currents and non-ferrous metals. This makes it extremely useful for metals such as aluminum, copper, and silver. Next, we have pure tungsten. It is a non-alloy that can be employed on welds that do not involve iron. And last, thoriated tungsten. This is the most commonly used type of tungsten electrode and is typically used on carbon and stainless steels.
Hi, I'm Rico Miguel Baldemoro, and now we will discuss the torch or electrode holder. The electrode holder torch is a tool that encloses the tungsten electrode and is connected to a set of cables that are in turn connected to the power source, and whose purpose is to supply electrical power and conveys the gas shield. For you to know, the internal metal parts of torch are made of hard alloys of copper or brass, so it can definitely transmit current and heat effectively. The body torch is made of heat-resistant materials such as insulating plastic, covering metal components. It is also the one the welder holds and manipulates to make the weld. Electrode holder has two variations, the automatic and manual torches. which are kinda similar in construction, but the difference between them was that the manual torch has handle, while the automatic torch normally comes with mounting rack. Torches have several components. The IG filler rod is one of the components, which most of the IG filler rods are mild steel, stainless steel, nickel, and aluminum. This filler material is a metal alloy specifically to handle different metals and was designed to withstand the high heat of welds and to fuse the two pieces of stock together as composite. So not surprisingly, the alloy and size of filler rods vary for the varying stock, thickness, and types of base metals people weld. And knowing which filler rod to use and when makes your welds strong and aesthetically pleasing.
I'm Macho Cadiao and we'll tackle the next component. It is what we call collet body, a mechanical clamping device or sleeve leg that uses pressure and friction to hold the tungsten in place and creates the electrical contact necessary for proper current transfer. The size of collet varies according to the electrode size so as to ensure proper and adequate contact for clamping the tungsten electrode. This also serves a more important function as it improves shielding gas coverage and joint accessibility. Next, we have inert shielding gases which helps to prevent weld contamination and electrode deterioration. The gas shield must prevent atmospheric contamination of the weld and not react with molten or solidifying weld metal or the tungsten electrode. The typical shielding gases used in TIG welding are argon, which is suitable for most applications, and helium that gives better penetration and heat input. This gas is more expensive than argon, and because of this is sometimes used as a mixture of 5% helium and 95% of argon for welding stainless steels.
I am JM Paano and I'm the one to report the ceramic gas. Nozzle direct the flow of a shielding gas around the electrode, the arc, and the multi-wheel pull. Ceramic gas nozzles are brittle, repeated heating and cooling makes them more fragile. A gas lens may be fitted to some torches when working into tight corners, etc. fillet joints, to improve the gas coverage and allow welding to be done with a longer electrode. The nozzle prevents the correct electrode to workpiece gap being achieved and the electrode must be extended. The gas lens allows this and at the same time improve a gas flow. Another one is sauce assembly. This carries the shielding gas welding current cable and cooling water pipes from the composite power source to the welding torch. Cooling water is needed where high current is used. For example, 80% continuous operation with current operation over 250 amps. The hose assembly carries an additional cable from the torch switch back to the power source, which allow gas, water flow, welding current, and high supply to be controlled from the torch.
Hi, my name is Nicole Magsino, and I'm here to talk about the primary function of power source or power supply. Power source or power supply are producing sufficient heat to melt the joint and to generate a stable arc and metal transfer. Welding power source for gas tungsten arc welding or GTAW can be defect alternating current, direct current, or both alternating and direct current in one machine. The most popular arc welding power source is the transformer rectifier type. This is machine produce both AC and DC current. In welding aluminum with gas tungsten arc welding requires an AC power supplies that break up the oxide that form on the surface when the metal is heated. However, in nearly all TIG welding application, DC with pulse current is superior. It allows greater control or bead formation in the heat input into the weld. A solidified weld metal is a cavity type of welding defect formed by gas entrapment. During solidification, as a result of contamination by certain gases such as hydrogen, oxygen, or nitrogen, porosity caused by hydrogen Pickup can be minimized by keeping the weld joint area and filler metal free of hydrocarbon contaminant and moisture. To avoid porosity caused by oxygen and nitrogen, it is important that the weld pool is properly shielded through the use of high purity shielding gases and sufficient shielding glass flow rates are being utilized.
For safety while performing gas tungsten arc welding, welders must wear protective clothing including light and thin leather gloves and protective long-sleeve shirts with high collars to avoid exposure to strong ultraviolet light.
Due to the absence of smoke in GTAW, the electric arc light is not covered by fumes and particulate matter as in stick welding or shielded metal arc welding, and thus is a great deal brighter, subjecting operators to strong ultraviolet light. You may also use modern helmets that often feature a liquid crystal type faceplate that self-darkens upon exposure to the bright light of the struck arc.
GTW has a lot of advantages, such as use for numerous metals, steel, bronze, nickel, brass, copper, magnesium, and gold. Second, produce welds without sparks, smoke, or fumes. Third, good for detailed design or curves. Fourth, can be used on thin and thick metals. And last, good for application that require an attractive appearance.
For the last part of our discussion, I would like to present to you the process on how the GTAW or gas tungsten arc welding performed, and to sum up all the mentioned materials, tools, and equipment earlier. As you can observe on the video, the weld area is protected from atmospheric contamination by a shielding gas. This is normally used for some welds known as autogeneous welds, which they do not require it. So you can also see the constant welding power supply that produces energy across the arc through the column of highly ionized gas and metal vapors known as plasma. As we know, doing this process needed both hands of a welder, and this is why they considered it as the most challenging process. To strike the welding arc, a high frequency generator provides an electric spark. This spark is a conductive path for the welding current through the shielding gas and allows the arc to be initiated while the electrode and the workpiece are separated. This is typically about 1.5 to 3 millimeters apart. Once the arc is struck, the welder moves the torch in a small circle to create a welding pool, the size of which depends on the size of the electrodes and the amount of a current. While maintaining a constant separation between the electrodes and the workpiece, the operator then moves the torch back slightly and tilts it backward about 10 to 15 degrees from vertical. After that filler metal is added manually to the front end of the weld pool as it is needed, welders often develop a technique of rapidly alternating between moving the torch forward and adding the filler metal. The filler rod is withdrawn from the weld pool each time the electrode advances, but it is never removed from the gas shield to prevent oxidation of its surface and contamination of the weld. If held too close on the arc, the filler rod can melt before it makes contact with the weld puddle. As the weld nears completion, the arc current is often gradually reduced to allow the weld crater to solidify and prevent the formation of crater cracks at the end of the weld. And that's the process on how gas tungsten arc welding performed. Thank you very much, everyone. I hope you found this discussion helpful and informative.
For our question, we have provided two. First, what are the causes of an unstable arc and how do you fix it?
For the second question, what causes porosity in a GTAW bid and how can it be avoided?